Okay, folks, today we're going to kind of review polynomials. We talked a lot about this in class, but it'll be good for you to hear it again, um, and then and hopefully you can use this as a review for the test when that comes up. Hopefully a lot of this is a review. Hopefully a lot of this makes sense. Stuff you've heard before, so hopefully this video doesn't get too long. And a lot of it we will have already discussed in class. Okay, here we go. General form. General form. Now in your book, there's a goofy way of writing this, and we will talk about what each thing means, but I want to write it down so you see it. A sub n x to the n, and this is on page 47. This is just a general polynomial equation. Plus a to the n minus 1, or a sub n minus 1, x to the n minus 1, plus, and then there's some dots in here, plus a sub 2 x squared plus a sub 1 x plus a naught. What does this mean? You look at this and it looks like alphabet soup, and you're like, what in the heck is going on? But let's just think about what is happening here. Let's just write down a polynomial equation and match things up. Let's say we have 2x to the fourth plus 3x cubed minus, I don't know, 7x squared plus 5x minus 1. Okay? Here's our polynomial. Well, if we look at this constant here is just a naught. Well, that means, since I used a's naught already, that means that this coefficient is a1, and obviously it has x to the first power. Okay? Well, that means the negative 7 is a2 because it's x to the second power. Notice how the a2 and the squared always go together. So why is it a to the n minus 1, a to the n? Well, whatever this thing happens to be, this thing is going to be the same. So if it was a and I had 7 terms, in this case I have a to the first, second, third, fourth. So we'll just use that so we don't get confused. I have a to the fourth, which means I'm going to have x to the fourth. This a sub 4, not a to the fourth, excuse me, I keep saying that wrong. A sub 4 just means I have 4 coefficients with variables. X to the fourth. Okay, a sub n minus 1. Well, if I started at 4, n is 4, n minus 1 is 3. So that's the third coefficient because obviously x is cubed. Okay, hopefully this makes sense. Now, if I start looking at coefficients, obviously a coefficient is anything that is multiplied by a variable. It's the number that is multiplied by a variable. So in our case, 5 is a coefficient, negative 7 is a coefficient, 3 is a coefficient, and 2 is a coefficient. Okay? Because they're multiplied by a variable. This negative 1 out here is called a constant, because the variable can't change it. This 5 I could change by making that x a 2, because 5 times 2 is 10. But the negative 1, there's no way I can change it because there's no x I can plug in to make it change. So it is constant. It is always going to be negative 1 at the end there. Okay? The degree of a polynomial is your highest power. So in this case, our degree is 4 in this case, because the highest power I have is x to the fourth. Okay? Hopefully that makes sense. The leading coefficient obviously is the coefficient that goes with the variable to the highest power. So x to the fourth is my highest power, so my degree is 4. That means that this 2 here is the leading coefficient because it goes with this term. This term is important. And the reason we pull these out is because it's going to help down the road with graphing. And in Algebra 2, we found that out. That knowing the degree, knowing the leading coefficient would help you out when you graph. Okay? I've kind of made a mess here, but hopefully everybody understands where that comes from. Okay? What each piece is. Coefficient, number multiplied by a variable. A degree, the highest power you have that is associated with a variable. The leading coefficient is the coefficient that is with your variable with the highest degree. Okay? And again, we'll review this over and over. Okay? Names. Names, names, names. We've got to give these things names based on their degrees. So again, the degree is the highest power. In your book, there's a whole list of examples and these names. Okay? It's on page 48. Okay? In a constant, the highest power, the degree, is 0. Because it's like 7x to the 0. What's anything to the 0 power? It's 1. Okay, we'll review that. So 7 times 1 is just 7. It's a constant. It's a number. I can't change it because the degree was 0. In a linear equation, the degree is 1. Like lines we've been graphing. Y equals 3x plus 2. Okay? A quadratic, which we went over and over again last year. It's x squared. And in the last chapter, we were factoring these. We were completing the square. It's all dealing with quadratics. Cubics. Your highest degree is 3. Quartic. Your highest degree is 4. And a quintic. Obviously, your highest degree is 5. We're not real concerned about the names past here because we really don't work with too many that get above here. But that's where you're at. Constant, your degree is 0. Linear, 1. Okay, such as something like this. Quadratic, 2. Cubic, 3. Quartic, 4. Quintic, 5. Hopefully that makes sense. Hopefully those names make sense. Zeros. We've talked about this over and over again in Algebra 2. But zeros are every place that the graph crosses the x-axis, because that's where x equals 0 is where those lines cross. Finding zeros, as we know from Algebra 2, is very, very important. Now here's what's going to happen, and here's something we talked about. Here's something we talked about last year. However, whatever your degree is, so if you have x to the 4th plus 7x cubed, blah, 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 and down the line, how many possible times could that graph cross the y or the x-axis? Well, if your degree is 4, it could possibly cross 4 times. So if it did, it would look something like this: 1, 2, 3, 4. Or it could go the other way, depending on if this was negative. 1, 2, 3, 4. Okay? Possibility of 4 times. So this leads us into end behavior. Okay? If your degree is even, what happens? The ends go the exact same way. Okay? Like a quadratic. Like an x squared. They both go up. If it was negative, they'd both go down. Okay? If it was positive, they'd both go up. If it was negative, they'd both go down. Even if it was x to the 6th, because if this thing could cross 6 times, 1, 2, 3, 4, 5, 6. Notice how they're all going to end up, both going to end up going the same direction. Even if it was negative. 1, 2, 3, 4, 5, 6. See, they're both going down even if it was negative. If the degree is even, they both go the same way. If the degree is odd, then what happens? Well, if the degree is odd, like let's say x to the 5th. 1, 2, 3, 4, 5. Uh-oh. If it's odd, they're both going to go opposite directions. Okay, this is the same. Notice how this end is going up, this end is going down if the degree is odd. Okay, and we can do this again. Let's go x to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. Opposite. Okay? Counting how many times I cross the x-axis, it ends up going opposite. Okay? And that's a little bit about the shape of the graph. That's kind of how we can tell, okay, what the shape of the graph is going to look like. Even if you have a big, long equation, you know, 3x to the 5th minus 4x squared plus 6x minus 3 equals y. Even if you have something like this, you've got an idea what the end behavior is. They're going to go opposite directions, okay? And because this is positive, it's going to have a shape like this. So you know that the end down here is doing this and the end up here is doing this. You know it could cross 5 times, but it doesn't have to. So it could go 1, 2, 3, 4, 5. Or it might only cross once. In this case, it could cross just once. Oops. It could go 1, 2. Could do this, right? Where these don't cross. Or it could cross 3 times, and that's it. Just kind of depends. But the general idea we know. We have a general idea what those graphs are going to do. Okay? And I didn't put in the imaginary numbers, but let's talk about that real quick. Imaginary numbers and what's going to happen there. Let's say I have an x squared plus 3x minus 1 equals y. I'm graphing this, okay. What happens if the graph doesn't cross the x-axis? What are your answers going to look like? If it crosses, you're going to get real answers. If it doesn't, you're going to get imaginary answers. This is why sometimes when we do the quadratic, we end up with 3 plus or minus 2i. You have 2 imaginary answers, which just means that the graph never actually crossed the x-axis. So again, another thing you can look at to see whether you're on the right track or not. Kind of get that general shape of the graph using imaginary numbers. Again, we'll review all this again. We talked a lot about it in class. But there's everything we've done, everything we've talked about. We'll review again, and hopefully this all makes sense.